Hello, can you hear me, guys? Hear me? Okay, so I'll start now. Okay, so I think in the last class we have classified partial differential equation of order one. Okay, so have you understood the classification? And before that, formed partial differential equation. That is how to form partial differential equations. And there are two methods. One is by eliminating arbitrary constant, and another one is by eliminating arbitrary functions. Okay. Then we have classified the first order partial differential equations in four categories. Among them, one is linear, semi-linear, quasi-linear, and fourth one is non-linear. Okay. Can you hear me?
Yes, sir.
Yes, sir.
Okay. Okay. So today we'll uh, start solving partial differential equation. Okay. Uh, Before that, we have just formed partial differential equation and classified. But today we'll discuss how to solve a differential equation. Okay, and throughout our course, our aim is to solve a differential equation. Okay, and this is the very important task for a differential equation. Okay, so first of all, we'll solve a first order linear differential equation. Then we solve second order differential equation. Okay, and second order differential equation of constant coefficient is in your course. Okay, but variable constants is not in your course. Okay, then we'll discuss solving wave equation and heat equation. Okay, and there is a Laplacian also. These are the three special categories of differential equation of second order. Okay, then we have Fourier series and Fourier sine cosine series. Okay, we'll do later on this type of things. Okay, so first I'll introduce how to solve a partial differential equation of second order, first order. Okay, you know basics of ordinary differential equation, how to solve a ordinary differential equation of first order or higher order. There are various methods you applied and solve them. Okay, so here also we'll understand how to solve a first order linear partial differential equation. Okay, and among the four type of equation, there is a quasi-linear equation that is the most important. Can you tell me someone what is quasi-linear partial differential equation? When you say an equation is a quasi-linear, can someone tell me? When you say that a first order partial differential equation is quasi-linear, how will you find understand that given equation is quasi-linear or semi-linear? Okay, before solving an equation, you have to understand which type of equation is given. Any guess? Anybody? None. When you say an equation is quasi-linear, this is the basics. Okay. when we say linear, you have me or you don't know that? Confirm. If an equation is of the form, okay, p x y z and small p plus q x y z small q equals to r x y z. Okay, if a given differential equation is of the form
স্যার কোনো
pp
কিছু শেয়ার
plus
হচ্ছে
q
না তো
equals to r. Yes. Oh,
স্যার স্ক্রিন শেয়ারে
sorry.
বা কিছু হচ্ছে না
Just wait. Sorry. Okay, now
ইয়েস স্যার
can you see the screen? Okay,
यस सर आ गया
take care. So, if a given differential equation is of this form, okay, p x y z p plus q x y z q equals to r x y z. That means if a given equation is linear in p and q only, okay, then you can say that a differential equation is quasi-linear. Okay,
যে এখন শেয়ার করছে
okay. So now we discuss method how to solve this type of differential equation. Okay. Who is there? Turn off your mic. Okay. Let's put this equation as number 1. Okay. An equation of the form an equation of the form 1 is known as quasi-linear, or sometimes this is called known as Lagrange Lagrange's equation. Okay, so this is your Lagrange's equation. Now we are applying a method to solve this type of equation. So that method is Lagrange's method. Okay, type of equation we have to form equation of the form, okay, like this dx over, can you know what is simultaneous differential equation? Do you know what is simultaneous differential equation? If equation is written in the form dx by p equals to q divided by r. This is your simultaneous equation where in denominator there is a capital P, that is coefficient of small p, and in the denominator of second term below dy this is capital Q, and below digit this r. Okay, so this is your standard form of Cauchy linear equation, and this is the converted form, and this is your equation. This is known as Lagrange's auxiliary equation. Okay, this equation 2 is known
Sir,
as,
your voice is breaking. Sir, your voice is breaking.
I think it's there will be network issue. Okay, because weather is changing, so there will be network issue. Okay, now can you hear me? Okay, now can you hear me?
Yes, sir.
Okay, so equation 2 is equation 2 is called Lagrange's auxiliary equation. Lagrange's auxiliary equation. Auxiliary equation. Okay. Now to solve this equation, you can see equation 1 is your partial differential equation. Okay. But can you tell me equation 2 is in which form? Equation 2 is in now in ordinary differential equation. Okay. You can clearly see from here that equation 1 is your partial differential equation, but when you write this equation, that is Lagrange's auxiliary equation, this is your ordinary differential equation. Okay, now to solve this equation 1, you have to solve equation 2. Okay, so now your aim is to solve this equation, and now you can solve this equation by using Lagrange's method. Okay, that we'll discuss here. Lagrange's method to solve Lagrange's method. Okay, so write down the general solution of Lagrange's equation. The general solution, the general solution, the general solution of equation 1, Lagrange's equation, Lagrange's equation 1 is phi of u comma v equals to 0. Okay, where phi is an arbitrary function. Write down where phi is an arbitrary functions. Okay, and arbitrary functions, and u of xyz, u of xyz equals to c1, and v of xyz equals to C2 are independent solutions to independent solutions independent solutions of equation 2. Okay, that is, when you solve equation 2, that means the Lagrange's auxiliary equation, you got two solution uxyz equal to C1 and vxyz equals to C2, and the combined solution of the equation 1 is phi of uv equal to 0, and this gives you the general solution of the original equation 1. Okay, where C1 C2 are arbitrary constant, where C1 and arbitrary constants. Okay, this is the result to find a solution of equation 1. Okay, so now we'll discuss how to start or how to solve an equation, and I'll write the steps here. Okay, and write one thing that at least at least one of u and v must be or must contain at least one of u z. Okay, where z is your dependent variable. So when you find the solution of the form u of xy equal z equal to C1 and v of xyz equal to C2, then at least one of u and v must contain z. Okay, if u and v not contain z, then you cannot find the solution. Okay, so because in general solution there must be a dependent variable. Okay, so now I'll discuss how to mm, find a solution and write the working rule. Okay, working rule for solving working rule for solving equation 1. Okay, by Lagrange's method. Lagrange's method. Step 1 is first step. Write down step 1. Okay, first write the standard form of the equation. Okay, write the given equation. Write the given equation standard form standard form as pp plus qq equals to r. Okay, so first of all, write the equation in standard form. Okay, always the given equation is not in this form. Okay, so first of all, you have to write the given equation in standard form as pp plus qq equal to r. Okay, then second step is write the Lagrange's auxiliary equation. Write down Lagrange's auxiliary equation. Lagrange's auxiliary. Sorry, this is auxiliary equations. Okay, for equation one
Sir,
as yes,
Lagrange portable equation.
this is Lagrange's auxiliary equation. Okay,
Okay.
Lagrange's auxiliary equations for this equation one as d by p equals to dy by q equals to dz by r. Okay, this is your Lagrange's auxiliary equation. Then solve equation 2. Now step 3 is solve equation 2. Okay, by by methods of ordinary differential equation. Now equation 2 is your ordinary differential equation. Methods of differential ordinary differential equations. Okay, then write down now let u of xyz equals to c1 and v of x comma y comma z equals to c2 be two independent solutions of equation 2. Okay, then in step 4, write down the general solution the general solution general solution of one can be written as phi of uv equals to 0, or u as a function of v. You can write the general solution in any of this form, okay, or v as a function of u, okay. So these are the steps to follow for finding the solution of this equation 1, okay.
Yes,
You have
sir.
any doubt?
No,
So
sir.
just
No, sir.
follow these 4 steps to find the solution, okay. First of all, you have to write the given equation in your in standard form pp plus q equal to r, okay. Always the equation is not in this form, okay. So you have to write first in this form, then write the Lagrange's auxiliary equation, okay, and then find the solution, okay, of this equation 2 as u and v, and then write the solution of this form phi of u equal to 0, or u equal to phi v, or v is phi of u, okay. These are the steps where phi is arbitrary function, okay, clear.
Yes, sir.
Now depending on the, you can see here p in the equation 2, in denominator p, q and z, p, q and r, and p, q, r are the functions of x, y, z, okay. May, so there may be a some p or q where p is only function of x, q may be a function of xy, r may be a function of xyz. There may be a some terms where there is a common term, okay, maybe here xy and here yz. So y and x may be a common, okay, or maybe here y square and this is xy, or in r there may be a term where common term is y, okay. So there may be a different type of p, q and r. So depending on the choice of p, q, r, there are some rules to find the solution, okay. You cannot directly find the solution. So to find the solution, it depends on the variety of p, q, r given in your equation, okay. So first rule to solve this equation is given as follows, okay. Just write here. So before discuss the rule 1, I'll just give you an example as follows. Look at C as dx by xy equals to dy by y square equals to, okay. Don't write this, just for understanding I'll mention later, okay, z, okay. Just for understanding, I write here dx by xy dy by y square dz by yz. This is an auxiliary equation, okay. Now to solve this, you have to take one pair at a time, okay. You cannot solve all these three at a time, okay. If you have given this type of equation, so you can just take one pair at a time, okay. So to solve this type of equation, this pair depends on the choice of the denominator, okay. So you can see, if you take the first pair, then there is a y term common, okay. If you write this term as dx this by xy equals to dy by square, this is one pair, and you can write this as another pair dy by y square equals to dz by yz. Okay, so here y cancel out from both sides, so you can write this as dx by x, and this can be written as dy by y. Okay, and in this case there is a y common from both sides, so y cancel out, so this will be dy by y equals to dz by z. So you can see here that because of the simplicity of the terms in the denominator, you can choose these two pair, and this is a one differential equation, and this is your ordinary differential equation, and this is a another differential equation, this is also ordinary differential equation. Now on integrating you can easily find the solution of this two equation. Okay, so depending on this p, q and r, you can apply different kind of methods to find the solution. Okay, so write down rule on to solve this type of equation. Rule on for solving rule on or for solving dx by p equals to dy by q equals to dz by r. Okay, this is the rule on. And put this as equation 1. So first of all, that one variable suppose one variable is absent or cancel out from any two fraction of the given equation, from any two fraction of given equation 1, then an integral can be obtained. Then one equation can be obtained by the usual method. Usual method. Okay. The same procedure can be repeated to find another set of two fraction. The same procedure the same procedure can be repeated for finding another solution. Okay, so in equation 1 there may be one variable missing, or maybe one variable is cancelled out from other two fraction of this equation. Okay, there may be a one term from these two fraction, or maybe a one term in this two fraction. Okay, when you cancel out, then you get one solution, and using the same method you can solve this equation. Okay, so I'll give you an example, then you understand better. So see this example. Solve y square p minus xy cube equals to x into z minus 2i. Okay, y square p minus xy cube equal to x into z minus 2i. Okay, so can you solve this equation? So just apply the method. What will you do first? Solutions. So this is given in standard form. Okay, what will you do next? Lagrange's calculations are here. Lagrange's auxiliary equations are dx by y square equals to dy by minus xy equals to dz by x into z minus 2i. Okay, this is the Lagrange's auxiliary equation. Now what to do? What is the next step? Tell me, what is the next step?
So we will take the first two,
Okay,
like
now
dx by
find,
y
you have to
square is equal
find
to dy by minus
find
xy.
solution of this equation. Okay, then which pair is okay? So first take first two fraction. Okay,
Yes, sir.
taking the first two fraction of 1, taking the first two fraction of 1, then what will you get?
So dx by y square is equal to dy by minus xy.
Okay, we get,
One y will be cancelled out.
okay, this will be dx by y square equals to dy by minus xy. Okay, then y cancel out, then you can write this as dx by y equals to dy by minus x. So you can write this as x dx, okay, x dx plus y dy equals to 0, okay. So now integrate this.
So x square by 2, y square by 2.
Okay, so put this as integrating 2, we have x square plus y square equals to c1, okay.
Yes, sir.
So you can write arbitrary constant as your choice. So this is, put this as equation number 3. So this is your first solution. Now we have to find another solution, okay. So which fraction you take? Which fraction you take? So to find
So
this
dy
another
by
solution, okay.
minus xy is
Yes.
equal to dz by x into z minus 2y.
Okay. Can you
One
take
x will
first
be
and last
cancelled.
term? Can you take
Uh,
first and third term?
no, sir,
Okay. Why?
because there is no chance of cancel out of y.
Okay. No chance of cancellation, and the most important thing is that here dx by y square and here dz by x into z minus 2y. Okay. That is, your operator is on x and z, but here your variable is y also. Okay. So you cannot integrate with respect to y. Okay. You cannot integrate with respect to y because your operator is dx and dz, but here your variable is x, y, z. Three terms are present, so you cannot take 1 and 3. Okay, so take first and last second two term. Okay, so then now taking the last two fractions, now taking the last two fractions of 1. Okay, we have, what will have, dy by minus x dz by x into z minus 2y. Okay, so x cancel out from both side. Now simplify this equation. What will you get? Simplify this equation. This is dy by minus xy equals to dz by x into z minus. So this can be written as
Minus dy by
dy
y
dy by
is
minus
equal
y
to
equals
dz
to
by z minus 2y.
dz by z minus 2y. Now how will you solve this equation? This is your ordinary differential equation. So how will you solve this equation? Can you solve this? Can you solve this equation?
No, sir.
Dy by minus y equals to dz by z minus 2y. This is your ordinary differential equation. Can you solve this equation? This is your ordinary differential equation. Can you write this equation as, can you write this equation as dz by dy form? If you write this as dz by dy, then this can be written as minus z minus 2y divided by y. Okay, if you just divide this dz by dy and just take z minus 2y in the numerator, so you can write this equation as dz by dy equals to minus z minus 2y by y. Okay, so can you write this as dz by dy, and if you divide by y, then this will be your minus z by y. Okay, so this can be written as plus z by y equals to, this is minus minus plus and y cancel out, so this can be written as 2. So this is your dz by dy plus z by y equal to 2. Can you tell me which kind of equation this one? This is your
Linear
first
differential.
coordinate equation. Okay, so this is linear. Okay, this is linear, first order linear differential equation. And now you know how to find the solution of linear differential equation. Okay, so can someone tell me how to find solution which is linear? So now you can put this equation as number 3 or equation number 4. Okay, which is linear, which is linear in z and y. Okay, so our find solution of linear differential equation. If you have given that dy dx plus px y equals to qx, okay, this is your linear differential equation in x and y. So when this type of equation given, then how will you find the solution? Can somebody tell me? You have learned in your previous semester, I think. If a given equation form dy dx plus pxy equal to qx, then what will be the solution of this equation?
Sir, we take the integrating factor.
Okay, first you have to find the integrating factor. Okay, so what will be the integrating factor here? How to write integrating factor?
So e to the power
E to the power
integration of
this
q
px
px.
dx. Okay, this is integrating factor. Okay, and next step, and now how to find the solution? How to write the solution?
Y into
Y into
integrating
integrating
factor
factor equals to integration of qx
q qx
integrating
into
factor
integrating factor into
x,
dy.
then plus c. Okay, okay, into dx. Okay, y into integrating factor equals to integral of qx into integrating factor dx plus c. Okay, this is the solution. Okay, for a linear equation. Now here this equation is linear in z and y. So what will be the integrating factor here? Therefore, integrating factor is, what will be the integrating factor? E to the power integral of 1 by y dy. Okay, so what will get? E to
It
the
is
power log
log
y.
y.
Log y, that means
Y.
e to the power log y is y.
Yes,
Okay,
sir.
so this is your integrating factor. Now what is the solution of equation 2 4? Therefore, solution of 4 is, therefore
Z into
solution of 4 is z into y
y is equal to integration of
equals to integrating 2 into
2 into
y.
y dz.
Okay, then dz, dz or dy,
So dz.
not dz, dy. Okay, there will, when, just see here, when this y is
Yes,
here
this is dy.
dependent variable. Okay, this is dy.
Yes,
So
dy.
plus c2. Okay, so when you integrate this, what will you get?
2y
This
square
may
by
be
2.
written as 2y square by 2. So 2 cancel out. So this will be your y square plus c2. Okay. So now you can write this as yz minus y square equals to c2. Okay. So write this as equation number 5. Now you have got previously that x square plus y square equal to c1 and yz minus y square equal to c2. Okay. So you got two solution. So you can write now your general solution. Okay. So what will be the next step? Therefore, the general solution, and you can see in the second solution z present. Okay. So our work is done. So the general solution of the given equation is, how will you write the general solution now? How will you write the general solution? Pi of ub. What is u? U is your first x square plus y square. Okay. Comma yz minus y square equals to 0. This is your general solution. Okay. This is the required solution you have to find out.
Yes, sir.
Okay. Any doubt up to this? This is the solution of this equation. Okay. So if you have any doubt, then you can ask me. Okay. This is the first rule to find the solution. Okay. And you have to write this type of things. Okay. You cannot write directly that this is auxiliary equation and just find the solution. Okay. You have to write this thing also, that taking the first two fraction, which fraction you have taken, you have to mention that. Okay. This sentence are very important. You cannot just write the fraction and find the solution. You have to write this. Okay. So any doubt?
No, sir.
Okay. So this is your rule 1. Now one thing, uh, just remember that to solve a partial differential equation, give your ordinate differential equation also. Okay. So to solve this type of things, just remember or just check your ordinary differential equation textbook. Okay. So now write down another example. I will give some examples to solve. Okay. For homework. Solve number 1. Y square z by x y square z y square z p plus x square zq x square zq equals to xy square, and number 2, x square p y square p y square p plus x square q equals to x square y square z square. Okay, these are the two examples. Okay, solve in your own. Okay, this is the rule one. You have to apply rule one, and these two are given in your standard form. Okay, so just find out the solution for this type of equation. Okay, so now I'll mention rule 2 for finding the solution. Rule 2. Okay, for finding the solution, suppose that here you have to follow the previous method also. Okay, that is, one solution can be obtained by using rule 1, but another solution cannot be obtained using rule 1. Okay, so to find out the second solution, you have to use this method. Okay, so suppose that one solution of Lagrange's auxiliary equation, Lagrange's auxiliary equations is known by rule 1, by using rule 1. Okay, and another solution cannot be obtained, another solution cannot be obtained by rule 1. Okay, then on integral is then on integral then on integral integral is also known as solution, is also known as integral. Okay, or solution, then on integral or solution known to us, known to us is used to find another solution, to find another solution. Okay, do you understand? Rule 2 tells us that one integral can be obtained by rule 1, but second solution cannot be obtained by rule 1. So we have to use the solution which is obtained by rule 1, and that solution is used to find another solution. Okay, so that will be clear by this example. Okay, so just see this example. Okay, So this is an example. See this example. Solve z into z square plus xy z square plus xy into px minus qx minus qy equals to x to the power 4. Is this in standard form? Is this equation in standard form? This is not in standard form. Okay. So first of all, you have to write this in standard form. Given equation can be written as given equation can be rewritten as, what is the standard form of this equation? Write this as xz into z square plus xy p minus yz into z square plus xy into q equals to x to the power 4. This is the standard form. Okay. Now next step is to write the Lagrange's equation, Lagrange's auxiliary equation. The Lagrange's equation. Can you hear me?
Yes, sir.
Okay. So the Lagrange's auxiliary equation, I'll just write auxiliary equation as A dot E. Okay. Equations are, what will be the Lagrange's auxiliary equations? Dx pi, what will be in the denominator? Xz into z square plus xy. Okay. Then dy by minus yz into z square plus xy equals to dz by x to the power 4. Okay. This is the Lagrange's auxiliary equations. Okay. Now, first, which fractions you take? If you take first two fraction, then there is a common term z square plus xy and z. Okay. So taking first fraction, taking first, sorry, taking to first two fractions, of 2, we get, what will we get? X is x z into x is z square plus xy and z into z square plus xy. Two terms are cancelled out. Then we'll write as dx by x plus dy by y equals to 0. Okay, so this is your number equation number 3. So integrating 3, we have xy equals to c1. Put this as equation number 4. Now you can see that in equation 2 you have xz into z square plus xy and dy by minus yz into z square plus xy and dz by x to the power 4. And from this equation 2, if you take first two fraction, then you get one solution, but you cannot apply rule 1 here to find another solution. Okay, so you have to use this xy equal to c1 in this two term. Okay, if you use xy equal to c1, okay, in here, then what will you get? What will you get? From second and third term, okay, and using 4, so from second or last two fractions, sorry, so from last two fractions and using 4, we obtain dy by minus yz into z square plus, this can be written as now c1. Okay, this is c1 and last term is dz by x to the power 4. Okay, so sorry, this is so this is your xy equals to c1. Now if you take first and third term, okay, you cannot use last two term. Okay, so you have to take first and last term. Okay, second, just see, just omit this line. This is your xz. So this is your first, from first and third fractions, and using 4 we obtain dx by minus xz into z square plus c1 equal to dz by x to the power 4. Then you can cancel out x term, so this will be given as x cube dx. Okay, x cube dx, and this is your uh, there is no minus, this is in first term there is no minus term, so this will be x cube dx minus cube plus c on z into dz equals to 0. Okay, so integrate equation 5 now. Integrating 5 integrating 5 we can write this as x to the power 4 divided by 4 minus z to the power 4 divided by 4 minus c1 by 2 z square, and write this arbitrary constant at c2 by 4. Okay, so if you cancel out by 4, then this term can be written as x to the power 4 minus z to the power 4 minus 2 into c1 z square, okay, equals to c2. The value of c1, this implies x to the power 4 minus z to the power 4 minus 2 into c1 is xy, so write xy, this is z square equals to c1. So using 4. Okay, so this is another solution. Now your general solution can be written as, therefore the general solution is phi of x comma y minus comma x to the power 4 minus z to the power 4 minus 2xy z square equals to 0. This is your general solution. Okay, have you understand?
Hello, sir.
Yes,
Could you please explain us, yeah, sir, the
yes,
second one, like from
okay. So
first and third?
yes, so just see, rule 1 tells us that we obtain a first solution by using the rule 1. Okay, just take first two fraction, then you just cancel out z into z square plus xy term from both side, and you get the solution xy equal to c1. Okay, now you have to apply this xy equal to c1 in this fraction. Okay, see here, xy term is here and xy term is here, so you can use xy equal to c1 in both term, but you have to use this term also. So to find out the another solution, when you apply xy equal to c1 here and you take second and third term, then there is a y term and there z term also. Okay, but you cannot eliminate here x, okay, because here is a x term also, so you cannot find a solution by using last two term. So just take first term and second term, then see that when you put xy equal to c1, okay, then your first fraction is dx by xz into z square plus c1, and last term is your dz by x to the power 4. So you can cancel x from both side. Okay, so now your remaining term is dx by z into z square plus c1 and dz by x cube. Okay, when you cancel x, then this is x cube. So just take the terms left side, so just multiply x cube dx, and this z is multiplied inside the bracket, so this is your z cube plus c1 into dz. Now integrate this term. Okay, you get this and on integrating you get divided by 4. So I have just for simplicity take the arbitrary constant as C2 by 4. When you multiply it by 4, this is your C2. You can take arbitrary constant as in your choice. Okay, so just put the value of C1 here, you get the solution. Okay, clear?
Yes, sir. Got it.
Yes, sir.
Okay.
So is it the second or third class?
Yes,
So today is second or third class?
I think this is your second class.
Second class.
Am I right?
Yes, sir. It's second class.
Second lecture. Yes, yes. So this is your rule 2 for finding the solution. Okay, there is one rule, rule third also. So uh, can you give me your offline class tomorrow?
When, sir?
Tomorrow you have any free time tomorrow?
Sir, I talked to electrical CR, then I will confirm.
Online or offline?
Offline.
Offline. Okay, offline is better. Okay, so if you have any slot tomorrow, then you can inform me. Okay, I'll take your offline class tomorrow.
So
At
online
least
is
1.5 hour. Okay. क्या हुआ? Okay, so this is your
Sir, will you send this
yes,
PDF in group?
yes. I'll send after the lecture. Okay. So this is your rule 2. So for your, I'm giving you some problems related to rule 2. XYP plus y square q equals to zxy minus then p plus 3q plus 3q equals to z plus quat y minus 3x, and rule third is p minus 2q minus 2q equals to 3x square into sine y plus 2x. Okay, just solve these examples. Okay, so now I'll discuss rule third for finding this type of solution. Okay, in rule third there is a different thing. Okay, there is no missing term in the denominator. Okay, so in this case you have to use different type of methods. Okay, so rule third. Okay, so just see, if you have given, for example, that a by a1 by b1 equals to a2 by b2 equals to a3 by b3. Okay, this is given. Can you write this? Can you write this as by multiplying any function, say capital A1 into A1 plus capital A2 into A2 plus A3 into A3 divided by capital B1 into B1 plus B2 into B2 plus capital B3 into small b3. Okay, can you write in this form? In mathematics, if you have given a equal sign, then can you write this equal sign as by summing of the numerator and summing of the denominator? Can you write? This is the basics things of mathematics. You have given a equal sign in the form, then by multiplying some constant to the numerator and by some constant by denominator, you can add the numerator terms and denominator terms also. Can you add? This is a property. Okay, and I will use this property to find out a solution by using rule 2. Okay, so let p1, q1 and r1 be functions of x, y, z. Okay, write down. Let p1, q1 and r1 be functions of x, y and z. Okay, then by a well-known principle of algebra, principle of algebra, this is well-known principle of algebra, each fraction in one will be equal to, this is equal, each fraction this is each fraction each fraction each fraction of Lagrange's auxiliary equations will be equal to will be equal to okay, each fraction of, sorry, equal to p1 dx multiply p1 dx plus q1 dy plus r1 dz and divided by p1 capital P plus q1 q plus r1z r1 sorry r1 r. Okay, so just multiply the numerator and denominator by p1 q1 and r1 and just add the numerator terms and denominator terms. Okay, and each of the term is equal to this term. Okay, so this is your term. Now put this equation as a equation number 1. Okay, now if the denominator term, okay, if the denominator term p1 capital P plus q1 capital Q plus r1 r, okay, equals to 0, okay, then now see, if the denominator term is 0 in this fraction, then we can say that the numerator term is also 0. Okay, then we know that numerator numerator of 1 also numerator of term 1 is also 0. Okay, that is p1 dx plus q1 dy plus r1 dz, this equals to 0. Okay, so this is p1 dx plus q1 dy plus r1 dz equal to 0. So from this we can find a solution. Okay, on integrating we can find a solution from here. So which can be integrated to give x comma y comma z equals to c1, and this is a one solution. Okay, now this can be repeated again another solution. Okay, so this can be repeated maybe repeated. So that is when you multiplied by p1 q1 r1, then you get one solution. So again you multiply by another kind of p1 q1 r1, then you get another type of solution. Okay, so this may be repeated to get another solution, to get another solution v of x comma y comma z equals to c2. Okay, where p1 q1 r1 are called multipliers. p1 Q1 and R1 are called multipliers. Okay, so this can be a constant also. As a special case, as a special case, these can be constant also. Okay, P1 Q1 R1 may be constant also. Okay, you can take this as a constant also. Okay, so one example, type 3. Okay, for example, just see, solve this example, solve mz minus ny p, sorry, this is p plus nx minus lz, nx minus lz, q equals to ly minus mx. Okay, so this is your example, and to find this solution, first of all, write down the auxiliary equation. Okay, the Lagrange's auxiliary equation is the Lagrange's auxiliary equations are, first of all, write as dx by mz dy by nx minus lz equals to dz by ly minus mx. Okay, this is equation number 1. This is your Lagrange's auxiliary equation. Okay, now you have to see, just look at this equation, that is minus ny, nx minus lz, and ly minus mx. So you cannot eliminate any term from the denominator. Okay, so rule 1 and rule 2 cannot be applied to this equation. Okay, so for that we have to use the multipliers. Okay, so if you first multiply by l, m and n, then what will you get? Okay, choosing l comma m comma n as multipliers, as multipliers as multipliers we get from 1, what will you get? This implies l into dx plus m into dy, multiply each fraction, first fraction by l, second fraction by m, and third fraction by n, and add them, you will get n into dz divided by when you multiply this by L, this will gives you L into mz minus ny, then add and multiply by m into nx minus lz, okay, and c, and multiply last term by n, and this is ly minus mx, okay. So look at the denominator here. When you multiply this by L, this will gives you LMZ, and see here this term, this is M and this is minus LZ, so this is minus LMZ, so this cancel out, and this is your minus LNY. So when you see here, this is plus LNY, cancel out, so this is your plus MNX and this is your minus MNX. So this denominator is now 0, so you can write this as L dx plus m dy plus n dz, and in denominator this is 0, okay. So your denominator is 0, therefore you can write this as, therefore L dx plus m dy plus n dz equals to 0, okay. So now integrate this equation, okay. When you integrate, what you will get? Therefore, on integrating we get, what will you get? Lx plus my plus nz equals to c1, okay. So this is your first solution. Now to obtain another solution, you have to use another multiplier, okay. So now what kind of multiplier you choose? So again choosing x comma y, x comma y comma z as multipliers, when you choose x y z as multiplier and write, then you get x dx plus
सर
y,
आज के लिए इतना रहने दीजिए।
ये खत्म हो जाएगा यहीं पे, ठीक है। y dy plus z dz, then just finish this example, okay. X into mz minus ny plus y into nx minus lz, and this is z into ly minus mx. This becomes, so look at the denominator. When you multiply this denominator by x, then this is your mxz, okay. And look at the last term. When you multiply by z, then this is your minus mxz, this cancel out, and this is your minus nxy, and see here this is your plus nxy, okay, and this is your minus lyz, and this is your plus lyz. So denominator becomes 0. So this numerator is x dx plus y dy plus z dz, and denominator is 0, okay. Therefore x dx plus y dy plus z dz equals to 0, okay. Now integrate this expression. So integrating we get, what is the integration? This is x square plus y square and then z square. This becomes C2. So put this as number 3. Okay. Therefore, general solution is obtained as, so therefore the general solution is phi of Lx plus My plus Nz comma x square plus y square plus z square, this equals to 0. This is the required solution. Okay, ठीक है. So मैथ रूल थर्ड जो
Yes,
है
sir.
थोड़ा सा डिफिकल्ट है कंपेयर टू रूल 1 एंड रूल 2. ओके, सो इसमें मैं डिनोमिनेटर को चूज करना है ऐसे, उस हिसाब से मल्टीप्लायर देखना है कि क्या मल्टीप्लाई करने से तीनों का डिनोमिनेटर जो है ऐड करने से 0 आ जाए. ठीक है, तो डिपेंड्स ऑन द डिनोमिनेटर. ओके, हाउ यू चूज द मल्टीप्लायर्स. ठीक है.
Okay, sir.
Okay, so I'll just give you some examples for this kind of equations. Just 1 second. Number 1 is z into x plus y. Z into x plus p plus z into x minus y q equals to x square plus y square. Number 2, y cube, sorry, this is x into y square plus z, x into y square plus z p minus y into x square plus z q equals to z into x square minus y square. Okay, so these are the examples. Okay, so just try to solve this example. Okay, ठीक है. सो किसी को कोई
Yes,
डाउट
sir.
हो तो आज के लिए इतना काफी है. ठीक है.
Yes, sir.
Okay, if possible and if you have any vacant slot tomorrow, then just inform me. I will take your class tomorrow. Okay.
Okay, sir.
Okay, ठीक है, फिर यहीं पे स्टॉप करते हैं आज के लिए.
Yes.